In example 11, we are expected to prove that the cosec 4 raised to the power 4 theta minus the cot raised to the power 4 theta is equals to 1 plus the cosine squared theta over 1 minus the cosine squared theta. And what we should have on the left hand side, we can see on the left hand side we have the difference between two squares. And we know how to go about difference between two squares. We get this is an even power, this is an even power, and there is a negative between them. So we have difference between two squares. So what do? We take the square root of both sides and say the cosec squared theta plus the cot squared theta multiplied by the cosec squared theta minus the cot squared theta. And that is that. If you look probably on the first bracket, you have the cosec squared theta plus the cot squared theta. But it is the second bracket we need to concentrate on. Why do we need to concentrate on the second bracket? Because we can already see, according to identity number 3 here, the cosec squared theta can be written in terms of 1 plus cot squared theta. And this positive cot theta is going to cancel out with negative cot theta. So we're going to have the cosec squared theta plus the cot squared theta multiplied by 1 plus, because this is cosec, all these are cosec, 1 plus the cot squared of theta minus the cot squared of theta. And as you can see, we have cot squared minus cot squared is 1. So eventually, what we are left with is cosec squared of theta plus the cot squared of theta. And what is cosec squared of theta? This one is simply 1 over sine squared of theta. So 1 over sine squared of theta. And what is cot theta? Cot theta is simply this is 1 over tan theta. And 1 over tan is simply cosine over sine, because we know the tan theta is the sine of theta over the cosine of theta. So 1 over tan, which is now cot theta, is the reciprocal of this, meaning now the cosine is up and the sine is denominator. So, but it is square, so we have the cosine squared of theta over the sine squared of theta. And this is simply addition of two terms, whereby the LCM itself is the sine squared of theta, which is 1, plus the cosine squared of theta. That is it. But if you look at what we're supposed to show, it's like we are done with the numerator, but we are not yet done with the denominator. But if you look at the first identity, because here we are having the sine squared of theta, the identity tells us that the sine squared of x plus the cosine squared of x is 1. So we can make sine squared x the subject of the formula, and it's going to be 1 plus the cosine squared of theta all over 1 minus the cosine squared of theta. And this is simply what you're supposed to show up there, and hence shown. It is part B that we must look at closely, and part B is supposed to, we are supposed to prove the sec squared of theta minus the cosine squared of theta is supposed to be equals to sine squared of theta into bracket 1 plus the sec squared of theta. Probably we may not have so much to do on the left hand side, but let's first of all open the bracket here and see clearly and see the inside of the relationship of this equation. So on the left hand side we are going to have the sine squared, or rather the sine, let me not write in short form, the sine squared of theta plus sine squared of theta sec squared of theta. And we know what is sec squared of theta. Of course, the sec squared of theta is simply 1 over cosine squared of theta. So we can write this one, because we are proving to have some primary trigonometric identities or ratios, sine and sine. Let us also make this primary, and we're going to have the sine squared of theta plus the sine squared of theta times 1 over the cos, which means over the cos squared of theta. And at that point, it has given us something else. Of course, this particular arrangement gives us the tan squared of theta. So we are going to have the sine squared of theta plus the tangent squared of theta. That is what we are having from the left hand side. And you can see very well that we are supposed to show this is equals to this. We are supposed to show that the sec squared theta the sec squared theta minus the cosine squared theta is equals to the right hand side. But what we are having so far is the sine squared theta plus the tan squared theta, of course from the right hand side. But it is interesting, it is very interesting to realize or to remember that this sine squared theta can still be written in terms of the cosine squared. And we're going to have 1 minus the cosine squared of theta, because this is simply sine, plus what is the tangent of theta? The tangent of theta, if we come to relationship number 2, you will see that this can be written in terms of tan squared theta is sec squared theta minus 1. And that is just what we bring on board. That is just what we bring on board. So, plus another bracket, sec squared of theta minus 1. Having said that, having brought about that, you can already see that having brought that on board, it is very important to show that if you open off, we have to have something to do with 1 minus the cosine squared of theta plus the sec squared of theta minus 1. If we rearrange this, we are going to have the sec squared theta is positive. This is going to be the sec squared theta is positive minus the cosine squared theta, which is negative. And of course, we are going to have 1 minus 1. This one and negative 1 will cancel out, and we'll be left with our final submission that talks about the sec squared theta minus the cosine squared of theta, which is now on the left hand side. This is, and you can see now, since the right hand side is exactly equals to the left hand side, then we have really been able to prove that the sec squared theta minus the cosine squared theta is equals to sine squared theta bracket 1 plus sec squared theta, and that is it. We just have to show that the left hand side can be written in the same form or in the same way as the right hand side. All right.